I'll apply force F. This is M2. Let this be M1. The dimensions of this be H. And the width be, let it be B. This is rough. What is the maximum force for which the upper block will not topple on the plank? Find the maximum value of F, maximum value of force F acting on plank so that block will not topple on plank. Okay, how to do this one? So according to the question given, it is like this. So what we do is, so there's a plank here. It's a very simple. Don't get scared. Anything. Nothing to do. So this will accelerate. Here, how the friction will act? The friction will act here like this, and then the friction will be like this. This friction will accelerate it, and since let's assume no slipping, so what is the acceleration of system? F by m1 plus m2. Then let me describe this whole problem with respect to plank frame. A person standing on the plank will solve this problem. Any pseudo force will act? Yes. Then the weight m2g, or say this is m1g. Now tell me in what direction, if at all, if it topples, how do it will topple? It will topple about point P1 or P2. Friction, let me show, because it has, be careful, the friction on the block and on the plank. If at all, if it topples about what point? About P1 or P2? It will be about P1, no, not about P2. Because as I keep on increase this applied force, the normal contact, I'll keep on increase applied force. Then the normal contact will shift. So what is the permitted? So the normal contact, I'll show it here so that it will be easy for me. And this is N1. Try to look at now this one. This is M2G. Let's take some rough diagram. N1 is I'm showing here. As I keep on increase applied force, the pseudo force will increase. Then the normal contact will shift towards left. So how do you can say? You do anything, take torque about center of mass. Then the torque by friction will balance the torque about center of mass by the friction. We should balance the normal contact only. Sir, I think it should be right. Okay, we will do one thing. Some of you are saying it will act towards right. Any problem? What I see that it is not toppling. It is not toppling means you go for torque about center of mass. Due to friction, it will be anti-clockwise. Due to normal contact, anti-clockwise, and it will topple. No, but I'm seeing that it is not toppling. So therefore, we will balance torque due to friction, torque due to normal contact. So therefore, the normal contact must act here. Able to make it out? Okay, let's come for this one. So I'll get about point P. I'll go for torque. Net torque about point P should be 0. Wall will set up torque due to pseudo force M1A H by 2. It should be anti-clockwise. Torque due to weight M1G into B by 2 clockwise equal to 0. Why there is no torque due to friction and N1? They will intersect axis of rotation. So if you better will write all set equals 0. So what happened? This will be M1A H by 2 positive. This will be negative. This will be 0. This will be 0. So finally, what is acceleration we are getting? Acceleration should be equal to GBH. Then what is the force I should apply? F is equal to m1 plus m2 into A. So m1 plus m2 GBH. If applied force less than this, the block M1 will not topple on the plank. If applied force is greater than this, it will topple. We have also another thing, no? What is the thing? What is the maximum force for no slipping? What is this is what, shall we say like, shall we put a condition like this? F less than or equal to block M1 will not topple on plank of mass M2. I'll shift up a little bit. Will not topple on plank and complete description I'll show it, just you see once. So you can, it's not that toppling anywhere, wherever you want you can introduce, even in wedge constraint. Go back to laws of motion, you have several objects, no? Discuss all everywhere toppling there. Agree this? If applied force less than this one. Now similarly, what is the maximum force for no slipping? Mu s m1 plus m2g. The same ideas you can bring it. What force you should apply so that first you should topple before sliding, before slipping, or should slip before sliding. So then the relation between mu, g, b and h will come. Okay, I'll stop